of errors, how these errors can be minimized or eliminated, and what are these pharmacopoeias, how many types or how many pharmacopoeias officially we would refer. We would be discussing about those things. Coming to the first, let us see about what is error. Okay, you might have seen that in calculator and all, like when we are going to add some higher values or something like which is unable to detect, so it will give you error like that. So similarly, when we do for pharmaceutical calculations and all, when we are not getting, okay, when we are getting something different from the expected value. True value is nothing but we have certain calculations. Theoretically, we will do a calculation. Most of the things we will be like reactions are there. Most of the results which we get from the instruments, which has to be tabulated and all, there would be a certain theoretical value that we should be getting. That value, when it is not giving the exact or various values other than the true value, we call it as error. So it is nothing but the difference between the measured value of the true value, that is called as an error. So here, if we just simply do the differentiation between the experimental value and true value, we call it as absolute error. So here, this absolute error, sometimes it could be negative, it could be positive. You might be getting lesser readings than the true value, or sometimes you might be getting higher readings. So which means that there is something different, or there is something, what do you call, not correct in your instrument or your performing and all. So let us understand that why this sort of variation the value happens. And these things, like for example, if just we can take an example for recent COVID-19, which has recently happened. So if the person would have got a positive for the COVID, he would have gone for like if people is on the jobs, they have been given for a leave, unwanted for a long leave, until and unless they get a negative result, they can't go. Some people who are came from abroad, they are unable to go to their home, just because if the result, it would have been wrong, they might be have an error. What happened? Even though the person was not having the COVID, he was given the wrong wrong diagnostic results, and which led to all the problems. So likewise, this is only one example of COVID-19. Likewise, this could happen in our day-to-day experiment, in our industrial preparations and all. All these things could happen even in medical results also. A single positive or negative result can give a lot of complications can happen, and a person might not be having any disease, but still the wrong result or error in the result could lead into a lot of trouble to that person. So here, if we see, like if we try to screen, or if we try to see the sources, which are the sources from where this error could occur. So first and foremost source is a human source, like the qualification and the experience of the analyst who is performing the experiment is very important. If the person is not expertise in that performing that task or that diagnostic test or experiment, then obviously he will be not performing correct and he would be giving the wrong results. Next is instrumental and apparatus and glassware, where the instrument what you're using, if it is not correct, and apparatus what you're using is not proper, or it might be little defective, and the glassware might not be correct, that could also lead into errors. And next is experimental conditions where you're performing certain reactions, or certain reagents that require very low temperature to be happening. But if you're not maintaining such temperature, if you're not maintaining such environment, the results could be different. And constituent used in analysis means what we're using, the reagents, solvents, standards, what we're using should be of best quality. Then only we'll get the correct. And the most highly important one is the procedural or methodological error. Okay, if analytical procedure, what you're performing, if it is not correct, if it is wrong, what happened? Everything is correct, the instrument is correct, the person performing is correct, but what the book or what the standard he's referring, if it is not having the correct method in it, then also there might be an error, and it is very important here. So we need to be looking to only the standard text for identifying or performing the preparation of standards or performing the various analytical techniques. So errors, like if you try to classify these type of errors, that could be classified into two types, determinate error or systematic error, or indeterminate errors. Determinate error means we can identify the cause and we can rectify that. Okay, there is an account of rectification that can be possible with this determinate errors. So few examples for determinate errors are personal error. Like for example, a person is colorblind, okay, and he won't be able to see the colors. So when we are going for chromatography, okay, in that you might be seeing various color bonds, like color bands that will be obtained, and there might be a difference in the color change that could happen when there is completion of reaction when you observe the thin layer chromatography. Okay, likewise, there are certain things in which colors are important. So at that time, what happens? Like for example, when you are switching on instrument, there is a red light, then there's a green light, okay, off, on, like that. There might be indications that will be there. So if a person is colorblind, he won't be able to distinguish whether it is on, off, and on. So here it is a personal error that is specified to the person who's performing that. Okay, next, instrumental error. If you're using the wrong instrument, or pH meter is not performing well, or it is like electricity is not there, current is not properly coming in that, then it could lead into instrumental error. Next is reagent error, the error that can only introduced by virtue of individual reagents, like impurities inherited in the reagents, or high temperature, volatilization, or addition of certain elements that could have leading to wrong results or wrong extra reaction that was happening. That is related to reagent. And constant errors, that could be either independent of magnitude or measured amount. If you are calculating certain thing or weighing certain thing, if in that you're not taking a proper value, at that time you will be obtaining this constant errors. Next is proportional errors. In this, what happened? Error changes in the size of sample. Like for example, you have a procedure of performing for like a batch of 250 ml. A conical flask has to be taken and do and add 10 grams of reagent and all. Okay, but instead of that, you're taking a lesser sample. You're taking only zero point 0.2 grams, and according to that, you have decreased all the reagents. So there is a chances that you might be getting little error based on decreasing the size of the sample in such a way that it could lead into errors. Okay, and it could even affect the analytical procedure, because you might be using the same quantities. Accordingly, you are decreasing it, but when you are heating it, that time temperature has to be also modified. So you might be heating for the same time, but it could give you the different results. Errors due to methodology. This is very important in personal errors. In this, what happened, both improper or correct sampling, incompleteness of the reaction often lead to serious errors. You might have to complete, there's a procedure mentioned that it has to be done for 2 hours, 3 hours. You can't just stop it for 1 hour and try to complete the reaction and see the try to get the product. You won't be getting proper results. And few typical example is encountering in titrometric and gravimetric analysis. Okay, in that also minor change, simply if you're not using distilled water while performing this titrometric analysis or these analytical techniques, you would get the variable results, because the impure water might be having a lot of metals, a lot of salts in it dissolved, which could be giving you different results. Because when you're using for various spectroscopic techniques, these methodology and the equipment has to be checked properly. The proper standard procedure which has been mentioned, that has to be followed. If you're not following the procedure, if you don't know how to perform the procedure, then you should try to first check out to the experts of that methodology. Then only you can proceed with. Next is additive errors. So it observed that additive errors are independent of quantum of substance. Actually, like errors caused due to weights or loss in weight of crucible in which precipitate is instrumented. So sometimes you are a crucible, you are using it, and in that, what happened, due to minor when you're triturating it, a little bit of the crucible material also has been added into it due to this strong more triturating with the stronger force. So this has caused into error due to weight also got increased, and it has also loss in the crucible in which you're precipitating is incinerated. That's also caused this additive errors in which unwantedly the weight has been increased. Coming to this one, that is indeterminate error. So whatever we have discussed here, like additive error, additive to methodology, proportional error, constant error, reagent, instrument, and person, all are systematic. Means if you take a very good person, like expert of that procedure, person has to be good, and the instrument what you're using, all of them are standard. All pure reagent has been used, and you have observed the proper measurement and every amount correctly, proportions has been checked properly, and method has been confirmed by checking out that this is the perfect method for performing this analytical test, and additive errors also has been checked properly. Then you can ultimately decrease that determinate errors. But indeterminate errors, these are random. Actually, we don't know what is the source of cause. So that is why these are indeterminate or random, and they cannot be under control. Like these are mostly random, ultimately give rise to high well also as low results with equal probability. They neither be corrected nor eliminated because we don't know how they are happening. Okay, so that is this indeterminate errors that could happen. So here, how we can eliminate or how can decrease these errors. So like repeated measurement of same variable several times. Okay, there are certain features like that could lead into indeterminate errors. So here, if we need to weigh for many times, there might be chances that randomly it could cause into certain random error, or like while tearing the weight, there might be a difficult differences might happen. Both unpredictable or imperceptible factors are unavoidable. So like recognition of specific definite variables are beyond anyone's control. Like even everything we cannot identify at that certain moment of time, as well as electronic circuit that would happen, or like due to some vibrations or a certain like external noise and all, that could also lead into certain errors into instrument. Or so like a certain drift in the electric current might give you like most of the instruments are electronic. So in that, if you're not maintaining proper current also, in that if the certain drift in the current also might give it to little bit changes in the analyzer, and that could lead into maybe little bit errors. So usually for that avoiding, we use UPS and all that, so that they could provide a proper electrical connections and all. So here, minimization of errors. So we have seen that there are certain causes, determinate errors are there, indeterminate errors are there. But there are certain steps, if we follow properly, then we can minimize most of the errors. First and foremost, calibration of apparatus. Most of the people or most of the industries and institutes, they don't follow this calibration part, but this is very important. We need to check, calibrate the instrument regularly, whether it is giving or switching on, switching off, and the proper just testing it randomly regularly, because many of the instruments are not in the use. So what happened, we don't perform the calibration, and suddenly when we need to perform an experiment, when you're using it for the many after a long time, there might be a chances of error happening. And running a blank determination, usually in essays, most of the essays and determination, there would be a blank as well as the tests that will be performed in order to eliminate the error. As next is running a control determination. So without sample, running that and running a control along with the sample, as well as knowing the value, what could be expected. With that, we need to perform a test that would be also help us to check whether it is giving the proper results or not. Use independent method of analysis. This is very, very important, especially for chromatographic techniques. If you need to have like for paper chromatography, for liquid chromatography, for HPLC and all, for each and every type of chromatography, and for each and every type of amino acids or the reagent which has been used, there is a different solvent, different solid like mobile phase, different stationary phase. Independent methods are there for each thing. So that has to be used for performing, then it will be help in minimizing the errors. Next is running parallel determination, like performing. Usually in the labs, if you go in the colleges, mostly like at least 5 to 6 batches will perform simultaneously. So this is one thing that is good. Like in this, what happened? Even though like individually might be students might be getting little bit minor different results and all, but uh, collectively, there is a chance of decreasing the error if we know that what would the values nearly. So might be 2 to 3 batches might not be performing well. The one which is performing with the proper method and all, you will be getting the good results. So even when you are performing for analyzing something or testing something, you need to do a parallel test along with the not even single, at least 2 to 3 tests has to be performed so that to identify or eliminate the errors. Next, standard addition, like whatever the molecules or whatever the reagents that has to be taken, that has to follow based on the standards. Internal standards should be maintained. Like you should have a certain rules and regulations, like calibration of apparatus has to be done within every week or at least in a fortnight that has to be done. And then amplification of methods that has to be checked. Isotopic dilutions has to be performed. So how it can be checked, like for example, calibration of apparatus and application of corrections. All instruments such as weight, flask, burette, pipette should be calibrated. Appropriate corrections applied to the original measurements. Like if you need to check, burette is there, it is having 50 ml readings on that. So you need to just check once, like what the burette you're getting, what your burette you're having, is it having the proper values? Like if you decrease 1 ml, exactly 1 ml is getting decreased. So this is one thing that calibration we call it as. So we are checking, cross-checking the instruments, whether they are working properly, having the proper graduated measurements or not. Next is, in some cases where errors cannot be eliminated, it is possible to be applied correction for the effect that it produces. Like there's this impurity in a way, precipitate may be determined and way deducted. Like whatever the like way instrument you're using, if it is not tearing properly, or if you're not using butter paper, or like you're not tearing properly, that could lead into different errors like for the way. So that can be eliminated by checking it properly. Next is running blank. Usually, I said that mostly in essays and all, will perform a blank titration in order to avoid these errors. So here, a blank correction is undesirable because exact value then becomes uncertain and precision of analysis is reduced. So usually, large blank correction is not desirable. Minor blank correction is there that we can do. So object is to find out effect of impurities. Like if you are running a blank, what result is coming as per the expectations, whether the endpoint is near or not, we will get the sample. So we will know that, okay, these are certain impurities still there that is leading into this little difference. So that is why if we run the blank, we get to idea the effect of impurities. Okay, running control, like results found for the standard, result found for unknown, weight of the continued standard by weight of the unknown. So here, in this way, we will be obtaining the control determination and how the variation that is happening. So standard sample, including primary standards of sodium oxalate, sodium hydrogen thalate, organic arsenic oxide, benzoic acid, or steel making alloys and all, that can be included for identifying. So this consists in carrying the determination under nearly as well as possible identical experimental conditions. So use of independent method of analysis, like for example, iron may be first determined gravimetrically by precipitation, then followed by ignition of precipitate, then it may be determined trigonometrically reduction of iron and titration with standard solution. So such as potassium dichromate or ceric ammonium sulfate or cerium 4-sulfate. So here we can by cross-checking like independent methods, different methods if we check and we are getting the similar results, which means that, okay, the correct results are performing with the gravimetric also we got the similar, with titration also we got the similar results for that amount of iron. So that will help us to check the errors. And determination of strength of hydrochloric acid by both titration as well as standard solution of strong base, and precipitation by weighing as silver chloride, that can also be done simultaneously. And if results obtained by two radically different methods, it's highly probable that the values are correct within the small limits of errors. Means we are getting the concordant values with different means, which means that the values are correct. Limits of a little error is there, but still we are getting the correct values. running parallel determinations. Like while performing, we need to duplicate or mostly triplicate that 2 times, 3 times if you perform, and we are getting the similar results, concordant values we will take in like acid-base titrations. Why? Because in order to eliminate the errors. So agreement merely shows that accidental errors or variation determinate errors are nearly same in the parallel determinations. Standard addition, like a known amount of constituent being added in order to sample will then analyze for the total amount of constituent present. Like you should call it as back titration. Okay, back titration in which known excess standard KES. Known starts with K, so KES. Known excess standard is also being added in certain precipitation titrations in order to get the correct values. So this method is you'll apply for physical-chemical procedures such as polarigraphy, spectrophotometry, in which in order to get the accurate values, we will be performing, we are adding this known excess standard and will be checking out how much it has been utilized. So back titration, we call it as. Internal standards, like you should be having procedure particular value of spectroscopic chromatographic determination. It involves a fixed amount of reference material has to be checked, and based on that reference material, the standards has to be measured, and then the ratios of physical value, absorption or peak size, internal, all these guys has to be give a proper straight line. Then only we can further proceed with the procedure. Amplification method. It is used very small amount of materials to be measured, which is beyond the limit of apparatus. So amplification means when the standard has been given very small amount and your apparatus is very large, like 1 gram it is given and you have been given 1 liter of apparatus, like it's not that much possible. So we need to amplify, we need to increase the quantity and we need to do it accordingly. Isotopic dilutions means we are using isotopes here. We need to add radioactive isotope with the sample and element is isolated in pure form, which is then weighed. So radioactive isolation material is measured and compared with that added element. So in this way, we can eliminate the error. Now coming to next is like when we are measuring the certain things, we need to see about like when we are telling about error, we need to keep these concepts of accuracy and precision in mind. Okay, so what is accuracy and what is precision? So when a value which is very near to that of our measured value or expected value or true value, we can tell. So when the true value and the measured value, when they are very close, we tell it as accuracy, near to true value. For example, when you are taking this analysis, X analysis Y, okay, so if you compare, we are getting the standard value error of 0.25 with analysis X. This is actually Y, green one. So with analysis Y, we are getting 1.225. So which is the best? X is getting the more accurate analysis because the standard value difference with that of the true value is 0.25. Standard we are expecting to be 100 and we are getting the value as 99.7. So 0.25 difference. For here, we are getting excess of 1.225. So it is giving more error. Analysis Y. Okay, so that is why the red one, the analysis X has the more accurate analysis. So it is being done for paracetamol brand of tablet. So in this we have taken observation, and when we checked about the like assays 99.80, 99.90 observation has been done, and then when we check that analysis X got the more precise, more accurate value, for example. To be specific, and analysis Y is getting 1.225, which is having more error compared to that of X. Coming to this precision, a precision is nothing but a repeatability of a value. Like precision is defined as agreement between replicate a measurement of same quantity when you're getting something repeatedly at certain point. Okay, so we call it as precise, even though it is not near to that true value. If it is coming continuously at a specific point, we call it as a precise. For example, you can see here, it is having low accuracy, low precision. Like there are nearly 7 times the experiment has been performed. All are getting different results. So no accuracy, no precision. So here you can see that the center, we are not getting near to the center. It is very away, but it is having close values, very close values. So it is having high precision, but low accuracy. Similarly, here in this, we can see that Nearly 4 are at the target, but 3 are out. So it is having high accuracy near to this, but precision is not there. All are a little bit away from each other, not close. And this one, you can see that high accuracy, high precision. Precision means repeatability, closeness of the value towards a specific area. Okay, so that is precision. Whether it could be near to the true value or away from the true value. If you're repeatedly getting near the same point, we call it as precise. Coming to significant figures. Okay, so here, when we are tabulating something, when we are calculating the values, we need to see about this significant figures. Okay, so that numbers. So in this rules, there are certain rules, like it has based on decimal system. We will be getting a 1, 2, 3 certain decimal values. So in this, all 0 digits are considered as, all non-zero are considered significant. Okay, and all leading zeros are non-significant. If you're getting 0.00 something, those are considered non-significant. The numbers after the 0 points and all, even 0 it is there, it is not considered significant. 0 is considered significant only if it is between two numerical values, like 2008 it is here, or 3.002. These two zeros are also significant when they are coming between two non-zero values. Now, trailing zero rule. If the present is decimal, significant. Okay, 2.070. Okay, and if the present is without decimal, like without decimal, there is no point here, so then it is non-significant. If any value is present 10 power n, then considered as non-significant. Okay, so like 1.3 10 power something, then we will be considered as non-significant. Significant figures are measured of any instrument should not be greater than instrument limit. Okay, so like 1.001, 0.5005 grams, or 0.5501. Constant values like pi, no significant figures. Okay, so in this, we don't be having the significant figures in that. We'll be adding up in the way of fractions. Okay, so this is about the significant figures, accuracy and precision, and about the errors. Now let us see about pharmacopoeia. What is this pharmacopoeia? Pharmacopoeia is a collection of standard formulations. Like we have got this pharmacopoeias from the various ancestral sources. We got the various formulas, standard formulas, from which we can prepare various medicines and all. So these standard texts, standard books are regarded as pharmacopoeia. Pharmacon means drug, to make, how to make a drug, how to make a medicine. Okay, so we have a standard formula along with the description and standards. So list of pharmacopoeia based on various areas, like you have Argentine, Austrian, Belgian, Brazilian, but mostly what we consider is British, Indian, European, US. Okay, all different countries are having this different pharmacopoeias based on their region, but as we are like Indian pharmacopoeia is based on British earlier. So that is why British pharmacopoeia is also sometimes considered. And USP is also being there. And European pharmacopoeia is also being considered. So here, the first of official pharmacopoeia of India appeared in 1868, which was edited by Edward John Waring, because he has did this. He was the first scientist to first official pharmacopoeia of India that has appeared in 1868, which was edited by this scientist Edward John Waring. In pre-independence, British pharmacopoeia was used in India, BP, that was BP only. That in 1968, he just edited this BP and published that. Okay, colonial addendum of BP in 1898 has happened, which was published in 1900, and again as Government of India edition in 1901. And 1946, the Indian Pharmacopoeia has been issued. Okay, and this was done under the chairmanship of Sir S.R.N. Chopra, along with 9 other members, the Indian Pharmacopoeia list, and it was prepared by Department of Health, Government of India, 1946. And then 1948, after independence, started a committee for preparing Pharmacopoeia of India, which in this Indian Pharmacopoeia Committee, under the chairmanship of B.N. Ghosh, published the first edition of IP. First edition of IP is in 1955. These values, like all these are very important, not only for now, like even for your competitive exams. These years, like who was the one who has first edited our Indian Pharmacopoeia? Indian Pharmacopoeia was called as British Pharmacopoeia. After 1995, at 1995, we got our first edition. 1946 itself, they have started like they should be at an Indian Pharmacopoeia. So it is the letter in English. Almost all the titles, like wherever the pharmacopoeias will be there, given in Latin word titles, and it covers 986 monographs. Supplement of this edition published in 1960. Second edition was in 1966 under the chairmanship of Dr. B. Mukherjee. Official titles are given in English. Dosage were expressed in metric system, and tablets, injection have been given formulations of drugs. Like IP of 1955 have 274 monographs, and the supplements were deleted. 93 monographs were added. Okay, supplements to this edition was published in 1975. So in this again, 126 new monograph included and 250 monographs have been amended. And then in this 1975 cholera vaccine has been removed. Addition of IP was published in another like 1989, and 261 new monograph has been added. So addendum to IP again in 1989 with 46 new monographs and 126 has been amended. Again addendum 2 published in 1991 were 62 new monographs. Fourth edition of IP was published in 1996 under the chairman of Dr. Nityanand. It has been made effective in 1st December 1996. And again, it covers 1149 monographs, 123 appendices. It includes 294 new monographs, 110 monographs has been deleted. And addendum 1 has been made effective from 31st December 2000, where 42 new monographs has been added. Addendum 2 has been effective in 30th June 2003, where 19 more new monographs has been added. And veterinary supplement. Okay, veterinary supplement has been added to IP 1996, contains 208 monographs and 4 appendices. So in 1996, we have added a veterinary supplement to the IP. Earlier, it was not have. Now, from 1996, veterinary supplement has been added, which contains 208 monographs and 4 appendices. Fifth edition was published in 2007 and was published in 2008, addendum. And IP is present in 3 volumes. Volume 1 contains journal, notice and journal chapters. 2 and 3 contains journal monograph, drug substance, dosage forms, and pharmaceutical aids. Sixth edition, published in 2010. Sixth edition of Indian Pharmacopoeia 2010, published by the Indian Pharmacopoeia Commission, Ghaziabad. This IPC has been present in Ghaziabad. It is there according to the plan of completed through the untrying effects of its member laboratory over about 2 years. It subsedes 2007 edition, but many monograph of the does not figure in this. And this edition will be effective from 1st September 2010. It contains 3 volumes. Volume 1 contains notices, preface, and structure of the IPC acknowledgement. Volume 2, journal notices, journal monographs, dosage monographs, and pharmaceutical aids. And volume 3 contains drug substance, dosage forms, and pharmaceutical aids. The scope of pharmacopoeia have been extended to include many like products like biotechnology, indigenous herbs, veterinary vaccines, additional antiretroviral drugs, because advancement happened. National health programs were added, and drugs were and their formulations not in use now are omitted from this edition. Okay, a number of monographs of excipients, anti-cancer, and monographs of new chapter of liposomes has been also been added up, and chapter on NMR is incorporated in appendix, and the chapter on microbial contamination also been updated. And 7th edition of Indian Pharmacopoeia, IP 2014, published by Indian Pharmacopoeia Commission on the behalf of Government of India, Ministry of Health. Indian Pharmacopoeia 2014 is present in 4 volumes. Scope of pharmacopoeia has been extended. And this IP 2014 is important. It incorporates 2,550 monographs, drugs out of 577 are new monographs consisting of APIs, active pharmaceutical ingredients, and dosage forms from herbal products, etc. And in this, we have added antiretroviral, veterinary vaccines, herbal products, and all. Seventh edition list of 577 new monographs included in IP 2010, amended in 2000, but added in edition containing 3 new monographs and 313 new monographs. New drug substances has been added up in this, and it has 7 biotechnology products along with 19 new general chapters. In this, you'll be having radiopharmaceutical monographs, general chapter in which included this edition. So edition of Indian Pharmacopoeia 2014 is now under the printing and will be available stakeholders. So it is like 2014 has been there, and now we got even 2023. Recently also we have got the latest edition has been also been added up, but the 7th edition of the 2014 is of the IP 7th. Okay, so now coming to British Pharmacopoeia, which was published in 1864. It consists of 2 sections of part 1, which has Materia Medica, part 2, preparation of compounds. So second edition of BP was published in 1867, and fourth edition was published in 1898, and then the fifth was published in 1940, and eighth edition was published in 1953. So like it has been published annually every year. It will be published in total 7 monographs has been introduced for materials specified in traditional Chinese and medicines. Okay, so earlier the fifth edition, this BP was like nothing but the Indian Pharmacopoeia. Later on, this has been separated and it has got into different. Okay, so like British Pharmacopoeia was also there, and that was also been used by Indian Pharmacopoeia. Okay, so similarities were there, but now it has totally been different after the separation. So the term prolonged release has been replaced by slow, and term gastrocin has been replaced by enteric-rotating number of monographs in 2007. BP 2008 contains approximately 3,100 monographs of substance preparations used in practice. It has been made effective in 1st January 2008, and 2007 and 2009 given 6 volumes, and in which first and second contains medicinal substances, third contains formulated preparations, blood-related products, and fourth contains supplementary chapters, IR spectra, fifth contains veterinary, and sixth contains the pseudo-run version of this one monograph. So it's now it has 2010 is under the like formulation and like all. So in this on behalf of British Pharmacopoeia, MHRA, Medicine Healthcare Production Regulatory Agency, recently published British Pharmacopoeia 2010, and it officially corrects the standard of UK medicinal products. The standards of BP 2010 are legally active in UK from January 2010. And it has been like today it is used in almost 100 countries worldwide, because wherever the British rule it is there they will be follows this BP, and their formulations are according to the British Pharmacopoeia. So all European Pharmacopoeia 6th edition and materials has been supplement integrated into the text of British Pharmacopoeia, and the printed edition of 2000 comprises of 4 volumes and BP 2010 and single volume of BP veterinary. So again, it has been packed of 2013 is also being given. So 6 volumes has been there, and BP veterinary, again, it will be having 2013 separate, and in which 41 new BP monographs and 40 new European Pharmacopoeia monographs has been added, and 619 new amended monographs are there, and 6 new and 1 amended infrared reference spectras were added. And again, 2014 edition includes 3,500 monographs, and Human Medicines Regulations 2012. Global standards, again, the similar, like overall the globe, nearly 100 countries follow that. And new 2014 effective edition has 40 new BP monographs, 272 amended monographs, and 3 new supplementary chapters, 4 new BP wet monographs, and 4 new BP wet supplementary chapters. So USP, the first edition of USP was given in 1820, both in Latin and English. Then from every 10 years interval, they used to publish till 1942. After 1942, every 5 years, they used to publish a new edition. From 2002 onwards, annually, they used to formulate. So first national formulary of United States, USP National Formulary, we call it as usually. So it has eight supplements. First appeared in 1985, last in November 1988. USP 22 National Formulary 17, 1990 is the third revision that consolidated USP and National Formulary into single volume. An electronic version of USP National Formulary floppy disk was introduced in 1992, and it was published in Mumbai as an Asian edition in 1994. So still we also have this USP National Formulary. 19 appeared in January 2000, and USP National Formulary 35 appeared in May 2007. So this contains scientific standards of all the drugs, dietary substances, biological products, excipients used in dosage forms. And it contains 4,100 monographs and 200 general chapters. And usually it will be printed in 3 volumes. One will contain general chapters, 2 and 3 contains the various monographs. First supplement of USP 30 to 50 appeared in August 2007, and second in November 2007, which will consider official form in May 2008. From 2006, Spanish edition is also being published. Currently, 2014 is the latest one. So new heavier paper stock, complete table of contents, and convenient slipcase. United States Pharmacopoeia National Formulary 26, single volume combination of 2 official Pharmacopoeia, United States and the National Formulary, monograph of drugs as well as the preparations are present in that, and excipient monographs are included in National Formulary. So USP 32 National Formulary 27 contains more than 4,200 monographs, 200 general chapters covering general tests, display helpful guides and charts that make it easy to find the focus, and it creates in-house standards for operating procedure and specifications, enables validation of tests and against the proven benchmarks. And USP National Formulary 28, it contains 4,400 monographs, over 200 general chapters, and it has easy to read format, helpful guides with charts, ensures compliance with official standards, and facilitates new product development and approval. So we have National Formulary 29 as well as 35 USP 35 and National Formulary 30, which was applicable from May 12, 2013, May 12, 2012 and 30th April 2013. Coming to EU, European Pharmacopoeia, it started working in first act from 1964, and first was in 1967 published, and then second edition was published in 1980, and third was in 1997, fourth was in 2001, fifth 2004, sixth 2007, and the latest one is in 2013. So since the 5th volume, the Pharmacopoeia, published in 2 volumes. Volume 1 contains general chapters and 2 contains the substance monograph. Like European Pharmacopoeia, 8th edition, published in June 2013. It determines the requirements for the qualitative and quantitative composition of medicines. It covers the active substance and herbal origin medicines, even homeopathic preparations, stocks, antibiotics are also been included. And the European Pharmacopoeia requires a legally binding in the number of states, European Pharmacopoeia Convention and European Union. So this is about the various pharmacopoeia. So usually we would be looking after these 4 standard books: Indian Pharmacopoeia, British Pharmacopoeia, USP, United States Pharmacopoeia, and European Pharmacopoeia. Mostly as our Indian Constitution, we would be mostly associated with the IP. When we go towards preparation of any formulation or preparation of any drug or medicine, standards like when we go for limit tests or when we go for any essays or any standard preparations, we need to follow the methods, or we need to follow the procedure of preparation using the pharmacopoeia. Even in the like industrial preparations and even in the standard preparations, the formulations which are given in the Indian pharmacopoeia IP only being used. Like if you go towards the various like international medicines, or like if you go towards US, they will be following their USP, United States Pharmacopoeia for formulations. Like in that USP, you will be having like how the injection, how this injection formulation, like 10 ml, how it has to be performed, how to be using what additives has to be added. Just total formulations of all the pharmaceutical products from A to Z will be there, and in which whole details of how much quantity has to be taken, how it has to be added, and detail of the exact quantities of the ingredients has been mentioned. So based on that, the standard formulation medicines has been prepared. So these are the standards. Books, pharmacopoeias are nothing but a collection of standard procedural formulations that will be there. And this will help you to get the proper standard methods. Okay, like in order to prepare any medicine, we need to know like as like every time they would be every 5 years, every 3 years, they would be continuously amended, they will be continuously modified based on the new techniques. Like we can say that from the independence till now, the formulations, the medicines, the tablets, and all, they have been changed. Like new formulations every time, a new compound has been synthesized. As soon as a new compound has been synthesized, it will be again added up. Its formulation will be added up, and its use will be added up. And we are advancing in the technology. Like earlier, we don't used to have like automated tablet preparations or capsule methods. Okay, a mechanical was there, but now it has been automated. Most of the things are getting controlled by AI, and it is getting automated. So based on that, formulations as well as medicinal preparations also has to be modified. So that is why these pharmacopoeias has to be amended, modified, and updated continuously time to time. Okay, so that is why we have these many different amendments as well as updations will be done every 2 to 3 years. Because as we are advancing, as the new drugs, like earlier we don't used to have these many medicines, we don't used to have these many formulations, but now we got for a single disease or single disorder, we have multiple formulations that could be working, like based on the child, based on the pediatrics, based on the geriatrics, we have different formulations, we have different dosages, we have different chemical preparations. And if someone are resistant to certain disease, they used to be given with a different formula. They used to given with a different chemical molecule. Or like for kids, for infants, we need to take drops. For adults, we need to have solid dosage forms. Sometimes it is not possible, so we would be not possible to take from the oral dosage form. We need to take IV route. So all these things are there when we are considering the formulations. So all these things can be simplified when we are using a standard method for preparing all these medicines. And for that, we have these all pharmacopoeias. So whenever we need to have any medicine preparations, the standard methods has to be followed. Then only it would be like standard methods, which has been amended, latest methods, whatever the latest pharmacopoeia, it is being published recently, that has to be followed for preparing any drug or medicines. Then only will we get the proper therapeutic response from that. Any doubts related to this pharmacopoeia or errors? Okay, so just I'll summarize all the things again. So we have today discussed about what are the various types of errors. Okay, like errors. If we go towards the errors, these errors could be of these are nothing but the variation from the expected result values from the true value. Whatever the measured value we are getting, that will be different. That is called as error. So it could be of various types, determinate or indeterminate. Determinate errors are those which can be eliminated, and we can have a various techniques to eliminate that. We need to look after the various causing sources for errors, and then we can eliminate those errors. Okay, indeterminate errors that are random, that cannot be identified. So it is very difficult to eliminate those errors. But still, we have certain methods which we follow, as we have discussed. These are the things if we follow. Like minimizing of errors can be done by all these techniques like calibration, running lag, running control, standard addition, internal standards amplification that could help us to eliminate. So here we have this values that could be uh, found to be like either accurate or precise when it is very near to the standard or expected value, true value, then it is accurate. When it is repeatedly coming at specific place, we call it as precise. Okay, so then we have significant figures in which has to be considered important and which has to be ignored while checking the values that is mentioned. And coming to pharmacopoeia, these are the standard texts which includes the method to formulations and standard procedures to make the standards. So that is in this we have discussed about IP, Indian Pharmacopoeia, when it has been first published. And then we have seen about British Pharmacopoeia, and then we have seen about United States Pharmacopoeia and European Pharmacopoeia. What are the various editions when they have been published? So these are like values of the publishing and all. Then how many monographs and all that are important for your multiple choice concepts, which will become in competitive exams. Shall we end the session?
Yes, sir.
Okay, okay, that's it for today. Let's end the session. Thank you all.